All right, first section, order of operations. If we do the order of operations, we have to follow what order? Pendants, right? So parentheses, exponents, and then multiplication and division are have the same power, and addition and subtraction have the same power. So, any of the first three that you need to see on the board?
I have a question. So, when you multiply the 2 and the 5, you
Yes.
get 10. So would you add the 8 before you subtract the 6, or does it
Yes,
not
because
really
then I'm going to go left to right.
matter? Okay. And then you would multiply it by the 4.
Yes. But realistically, it really doesn't matter. Because you would have 10 minus 6 is 4, plus 8 is 12, and you would have 8 plus 10 is 18, minus 6 is 12. So it doesn't matter, but I would stay consistent and just work left to right. Everybody okay with those then? Second section, we're just basically doing expressions. What was an expression?
A question that doesn't have
Answer.
An equal sign, right? It still can have an answer, but it doesn't have an equal sign in the problem. Okay? So what has an equal sign? An equation, right? Expressions don't have an equal sign. Equations do, but they still both have an answer. Okay, so remember I can multiply anything together. So like in 12 and 13, even though there's variables in the problem, I can still multiply them together. You got to think about all of our rules for signs, right? If I'm multiplying and dividing, the signs, if the signs are the same, my answer is positive. If my signs are different, my answer is always negative. But that changes when we're adding and subtracting, right? If I'm adding and the signs are the same, I add and use that sign for my answer. But if I'm adding and the signs are different, I really what? Subtract, and then I use the sign from the bigger one, right? And then if I'm subtracting, I'm just doing keep, change, or I think most of you are pretty good at just looking at it as subtraction now. Like in number 11, notice that I had minus a negative. Anytime that I have back-to-back negatives, it turns into one big plus sign. So, any problems with 4 through 13? 13 should have been 10 dk. Right? So I'm just multiplying them together and then putting the letters together. 10 dk. But they're both negative, so I turned it into a positive. Okay there? Next section is about the coordinate plane again. So here's my coordinate plane. Make sure that you use a ruler and you draw your axes with a straight line. The green axis is my what? X. My yellow is my Y. Okay? So then when it asks us to put the quadrants in, the top right hand one is 1, and then we go where? Left. 2, 3, 4. I have to remember to answer those as, or write those answers as Roman numerals. Okay? And the Roman numeral for 4 is IB. Right? 1 less than 5. If it is right on one of the axes, you can either name the axis or say none for the quadrant. Don't say it's in between 1 and 4. Okay? Anybody need to see us plot a point? Next section was simplifying. When we're simplifying, this is where we introduce the cows plus the cows equal more cows. So they have to be the exact same thing in order for us to add. And again, something like r and r squared are not the exact same thing, right? They're both cows, but one's brown and one's black. So we can't still add them. Then when we're going to add them, we just add the coefficients or the number in front. Something like 17, the first thing I should do in number 17 is what? Before that?
Distribute.
Distribute, right? Take that 6 and multiply it through those parentheses. Because again, the order of operation says I need to do the parentheses first. So do I need to do 15 or 16 or 17 on the board?
Either one.
17. So 6 parentheses r minus 4 plus r plus 30 minus 7r. So as Mr. Kolbeck said, the first thing we're going to do is get rid of my parentheses. So again, distributing means I'm going to multiply the number on the outside to everything on the inside. But again, on the inside, don't forget that this minus sign really just says 4 is negative. So when I distribute, I get 6r minus 24. Everything else just comes down. Now I'm going to look for like terms, which means the exact same thing. So I'm going to combine the r's. If you want to rewrite it, rewrite it. Otherwise, I'm just looking. 6 plus 1r is how many? 7r plus minus 7r does what? Those all cross out.
So are your R's gone then too?
My r's are gone. Okay, because we're adding and subtracting. Right? If I'm dividing, then my r, or then I would still have 1. But because I'm subtracting, I'm eliminating them all.
And how do you know? Oh wait, no.
Negative 24 plus 30. So we should have got 6 for that answer. Make sense? Okay with those? 18 and 19, we talk about exponents again. Exponents is just a way of kind of shortening it up and writing it as a unit, right? So 18 should have been a cubed b squared. 19 should have been h to the 6th j. Hopefully that's pretty simple. 20 through 25, now we're into solving equations. So now we have an equal sign in these problems, and what is our main goal at the end? We want to get what?
My variable alone and positive.
All by itself and positive. The variable has to be, right? We don't care about the answer, but the variable has to be positive and all by itself. Any questions with any of 20 through 25? 24 and 25 would be two-step equations. When I do two-step equations, remember I just cover up that variable part, and I ask myself, how do I get rid of the other number first?
You do 24.
24. 24 says 12d plus 15 equals 3. So again, anytime that I do a two-step equation, I'm going to come up here and I'm going to cover up the variable part. So how do I get rid of a positive or a plus 15?
Subtract 15.
Whatever I do to one side of the equation, I got to do to the other side of the equation. I got the same number, but they have different signs, so I'm going to cross those out. I'm left with 12d equals how much? Negative 12, right? Then I just do the problem. And now I ask myself, if this is multiplication, how do I get rid of multiplication?
Divide.
Divide by 12. When I do that on one side, I got to do it on the other side. Negative 12 divided by 12 is?
Negative 1.
Negative 1. Should I miss any of the equation ones?
No.
Because why?
You can have 3 answers.
I can always check it. I can take that negative 1 and put it back into the original problem and solve it back up. Okay? Any others in that section? So again, notice my variables all by itself and positive. I don't care that the 1 is negative. The variable has to be positive. Next section, we talk about multiplying and dividing monomials. What's a monomial?
Term.
A term, right? What's a term?
Product? No. Product, number, or variable.
A number, a variable, or a product. And a product just means what?
Multiplication.
They're multiplied together. Easiest way to multiply a number and a variable is just squishing them together. Okay, so if I'm doing 26, what do I really do with my exponents? I add them because I'm multiplying. If I'm in 27, I really subtract, or I think about just crossing them out. Subtraction ones kind of get confusing once in a while if we get into the negatives, right? Can I ever have a negative exponent in my answer? No, how do I make that negative exponent positive?
Flip it over.
Move it over the fraction bar, right? From the top to the bottom or the bottom to the top. And then as it goes across that fraction bar, it turns into a positive. Make sense? Any of those, 26 through 28, you want to see on the board? 31 through 34, we're getting closer and closer to the things that we've done kind of recently. So if I'm multiplying by fractions, the first thing I look to do is what? Reduce. Even before I reduce probably is something like in 32, I need to turn both of those into what? Improper fractions, right? In 32, if that negative's in front of 2 1/8, make sure you don't use that negative when you do that process because it'll change your answer. Okay? In 33 and 34, can I divide by fractions? No, not really, right? So we do what? Multiply by the reciprocal, right? So we keep the first one, change division to multiplication, and flip or turn the second fraction over. Again, we want to make sure that we turn them into improper fractions before we do the multiplication, and you cannot reduce diagonally until you turn it into multiplication for 33 and 34. So any of those you want to see on the board? 32. So in 32, as the problem's given to us, the first thing that I notice is that I have mixed numbers. So the first thing that I'm going to do is think about turning these into improper fractions. So what do I get for the first one?
17.
Negative 17 over 8. Don't forget that negative sign. Times
Negative 32.
negative 32 over 7. Again, all we're doing is the denominator times the whole number plus the numerator. Okay, now we're ready to multiply, right? But before we multiply, now we're going to try to reduce if we want to. And what ways or directions can we reduce? Diagonally or up and down. Now, do I have to do that? Heck no. I could just multiply, but then at the end, my numbers get really, really big, maybe. So in this case, can I do any reducing?
8 to 32.
My 8 turns into 1, 32 becomes
4.
negative 4. Don't forget about that negative sign, right? And then I'm ready to multiply. And once I'm ready to multiply, don't forget I got to multiply across the top and the bottom. That's what's different between this section and the next section of adding and subtracting. So, 2 negatives, my answer is going to automatically be what? Positive. On the bottom, it's easy. What's 17 times 4? 68. Can I reduce 68 and 7?
No.
I don't think so. Leave your answers as improper fractions. Some of you still are doing mixed numbers. It tells me you're probably using your calculator. Don't use your calculator. Okay? Any others in that section? Back page. Adding and subtracting fractions. Again, I would simplify the process by turning all of them into improper fractions. The most important thing with adding and subtracting fractions is that I need what?
Common denominator.
Gotta have a common denominator. Number 35, it's done for me, I'm ready to go. 36 and 37, the first thing I have to do, again, I would turn them into improper fractions, then get my common denominator. The biggest difference between multiplying and dividing and adding and subtracting is once I have that common denominator, I just add or subtract across the top number. The bottom number is going to stay as my common denominator. So, any of those you want to see? 35 through 37. Wow, we're going to do really good on this. You guys are just smart, huh? Next section, measures of central tendency automatically tells you what?
Mean, median, and mode.
The mean, the median, and the mode, sometimes the
Range.
right? So we just started talking about when we're going to take the ISAT test or whatever they're calling now. So that's something that will probably end up on your guys' test somewhere.
The Iowa test.
Yeah, the Iowa assessment, now it's a different test.
Is
But
that Not all line.
Yeah.
It's not online now.
So, remember, measures of central tendency, that's what that means. And they'll probably use that as the title, so you don't get confused with that.
What if it wants to see if the range is roll up solids in a certain way?
Yes, then it would just probably say including the range or something. So what was my median? Or sorry, what was my mean? The average. Add them all together and divide by the number of numbers in the set. The median,
Put them in each greatest and go see which one's in the middle.
okay? Sometimes if I end up with 2 in the middle, what do I have to do?
Average.
The average, okay? And then the mode means
Most.
most common. Can I have more than one?
Yes.
Can I have none?
Yes.
Everybody good with that? What was the range if they would ask?
Subtract the biggest number from the smallest.
Biggest number minus the smallest number. And then what, they don't really talk about this, but what happens if I got a number that's really, really big or really, really small from the group? What did we call that?
Outlier.
An outlier, right? An outlier. So what, most of the time, or a lot of the times, we would take that outlier and throw it out, right? Because it's gonna distort our data. Okay? Anybody need to see 38? Any part of it? Okay, 39, sequences, arithmetic versus geometric. Arithmetic means what?
Adding and subtracting.
Adding and subtracting, it's going up, so we're adding, or down, it's subtracting. Geometric means, we can basically think about it as that, or we can just think about multiplying and then either multiplying by a whole number or a fraction. Those are kind of the same thing. So then I would name my common ratio or difference and then find the next 3 terms. So in our example, which kind do we have? Arithmetic, because it's doing what? Adding 8. So what's my next 3?
54, 62, 70.
Oh, okay, so you're really on top of that.
Oh, 'cause I had it.
Wait.
Oh, you already did that.
Oh.
Okay. You don't need it. Just don't hit yourself. 40 and 41. This is what we're gonna do tomorrow. Okay?
Was it kind of like the, like what we did in the.
This is why we learned what we learned today, or for today, the ratios. We're gonna take ratios, and if you take a ratio, which is the fractions there, and set them equal to each other, it's called a proportion. That's what we'll talk about tomorrow.
Where's the lesson we learned on Monday? On Tuesday, where is it?
We did the ratios and rates.
Oh, but it's not on there. Wait.
Sorry, I didn't put it on there. You want me to put it on there?
No.
Is
I
it
can
not?
put one of those ginormous conversions on there.
Is it not on one of the tests? Is it not on the test? Or is it on the test?
Yeah, there's a lot of stuff that we didn't review that's on the test.
I didn't know there was gonna be a question on there.
Don't know what I had on the review.
Mr. What day would we have?
Mr.
Mr.
Mr. Canizal, what day would we have you then?
What period is this?
4. Nathan, so we'll have him Friday.
Oh, we still gotta figure out that.
Yeah, because it's an odd.
Do it sometimes.